question is from the 2022 Mechanical Engineering paper set 2, question number 40. A spring mass damper system, mass m, stiffness k and damping coefficient c, excited by a force f of t, which is b sin omega t, where b, omega and t are amplitude, frequency and time respectively, is shown in the figure. 4 different responses of the system marked as 1 to 4 are shown just to the right of the system figure. In the figures of the responses, A is the amplitude of response shown and the dashed lines indicates its envelope. The responses represent only the qualitative trend and those are not drawn to any specific scale. 4 different parameter and forcing conditions are mentioned below. So P gives C is greater than 0 and omega is equal to under root k by m. Q says C is less than 0 and omega is not equal to 0. R says C is equal to 0 and omega is equal to under root k by m. And S says C is equal to 0 and omega is approximately equal to under root k by m. Which one of the following options gives correct match indicated by arrow of the parameter and forcing conditions to the response? Let's find this out. Now in first case P, C is greater than 0. That means damping is non-zero, damping is present. That too, the damping coefficient has a positive value. So definitely the amplitude should not be an increasing one, because as there is damping present in the system, the amplitude is eventually going to be decreasing or it will become 0 after some time. But in this case, it is also given that there is an external force f of t, which is equal to b sin omega t, acting on the system, and therefore the amplitude does not go to 0, but it is going to decrease eventually. So that's one hint from here. Also, it is given that omega is equal to under root k by m. So omega is the forcing frequency because it is the frequency of the forcing function or the external force f of t, while under root k by m is the natural frequency of the system. So we can see that when the forcing frequency becomes equal to the natural frequency of the system, which is omega n, we know that it is the resonance case. System amplitude becomes very large at resonance, and therefore we have to choose such a trend in which the curve that envelopes the amplitude should have a decreasing trend as well as the amplitude should be high, and therefore we can see that it's given in the first graph. So P matches with 1. Now Q is given to be C is less than 0. That means the damping coefficient value is negative. So the curve that envelopes the amplitude curve is going to have an increasing trend. Also, it's given omega is non-zero. That means the resonance condition is not given here. The forcing frequency has some value, but it is not equal to the natural frequency of the system. And that is why amplitude will be increasing. And therefore, we see that Q matches with fourth trend. Next one, R. R says damping is 0. And omega is equal to under root k by m. So because the damping is 0, we can say that the amplitude is going to go on increasing as there is an external force acting constantly on the system. Also, it's given that omega is equal to the natural frequency of the system and therefore the amplitude will be very large. So we see that R matches with number 2. Last one that is remaining, S, it will definitely match with third one. Also, damping is 0. And natural frequency is not equal to the forcing frequency and therefore the resonance condition does not occur. So S matches with 3. Let's go back and fill in this answer. 1, 4, 2 and 3. 1, 4, 2, 3 is given in option C. Option C is the correct answer. To learn more about forced vibrations, you can refer to the NPTEL video module 2 lecture 8 L8 forced vibrations. This lecture is from the course Soil Dynamics. The course is taught by Dr. Dipankar Chaudhary. He is from Department of Civil Engineering of IIT Bombay. I hope this solution helps you clear your doubt. Thank you.